I've had the opportunity to work in various roles throughout the software delivery lifecycle. There have been highs and there have been some lows in those experiences. Balancing the needs of the business and fighting fires can be really exhausting. Unhappy users isn't good for our users, our business, and as a recovering support engineer, it is definitely not good for the support team as well. So in this pursuit of figuring out, what the F is SRE, let's discuss why we want reliable and secure software. I'm Amanda Lewis, a developer advocate at Google Cloud.
My name is Sandeep, and I'm a DevRel engineer.
We only have 15 minutes for this quick chat, but if I had more time, it could have been fun, and I would love to have taken this to the street and asked some customers, developers, sysadmins, product managers, the very question, why do you want reliable software? But in the interest of time, I'll just proceed with some answers based on our research and experience. So we want reliable and secure software. But what do our customers want? Well, of course, they want new features, all the features, and they want them yesterday, right? Well, actually, it turns out that while they often want and enjoy new features, they actually want it all. If the service is down or they've rage clicked 1,000 times to add avocado to their order and nothing is happening, in that moment, they could care less if that new feature that would have allowed them to add less or more avocado to their order is available. All they care about is that they can't finish the order. So in that same regard, when they logged into the application, they 100% expected it to be secure, especially as they were adding their personal information. But if they were talking with their friends about it, they certainly wouldn't be, oh, it is the most reliable and secure application I use. They're going to talk about those features. And so the customer, they want it all. And they won't communicate that they want SRE reliability or maybe even the word security, but they will ask for those shiny new features. And so now the customer is asking for a new feature, so the product team is going to plan for adding that new feature, usually quickly adding it to the next sprint. And we've got our software engineers, and they're awesome, and they want the business to be successful. They want to make the users happy. So to the extent that they will keep prioritizing new features, even if and when things are getting tough for them. The business and IT teams don't always have a shared language to be able to communicate on how to prioritize new features. And to be truthful, it is pretty easy to measure the number of new features that are deployed and then reward on that. Then we have our ops team, and they're awesome. And they know that outages and security incidents are bad for the business. They are measured on the reliability and security of the service. So they're going to have a workflow that is going to prioritize what they're measuring and what they're focused on. And the business, well, it's focused on improving business outcomes. So really, the business wants it all, just like the customers, reliability, security, and new features. And the awesome thing is, we can have it all. The customers, the dev teams, ops, security, product, sales, and marketing, all of these teams can have it all. And we know they can have it all because we have research to back it up. DORA is the largest and longest running research project of its kind, providing an independent and tool-agnostic view into the practices and capabilities that drive IT performance. Rigorous statistical methods are used to present data-driven insights and the most effective and efficient way to develop and deliver technology. The State of DevOps results allow the whole industry to understand the practices that help deliver software quickly, reliably, and safely, and in turn, drive powerful business outcomes. In 2021, the topics included benchmarks for elite, high, medium, and low performers. They investigated the effects of SRE practices and secure software supply chains. There's a section that's committed to looking at distributed teams and the practices that can drive improvement to work-life balance and reduced burnout. We also investigated the impact of cloud, monitoring and observability, along with open source, and documentation's quality and the impact that it has on performance. So, we've said we can have it all, and there are elite performers that are doing just that. When we compare the low performers and the elite performers from the 2019 research, elite teams had 100 times faster lead times from commit to when it got to customers, 200 times more frequent code deployments, 7 times lower change fail rates, and 2,600 times faster time to recover. So let's fast forward 2 years, and then we're looking at the 2021 State of DevOps report. We saw some significant changes driven by increased performance across the board. Those elite performers, they pulled ahead in 3 of the 4 metrics. But you'll see with the change fail rate, the gap has gotten noticeably smaller there. So the research program found a valid and reliable way to measure software delivery. 4 metrics, which can be applied to any kind of software delivery. You have the 2 metrics representing speed, so your lead time for changes from the time it is committed to version control until it gets into production, and deployment frequency. Then we're also looking at stability, that change fail rate. When you push out a change, what percentage of the time do you need to remediate? And time to restore. So when you are remediating, how long does that take? The entire team that's responsible for the software should be collaborating on improving these metrics together. So the research, we have the 4 key metrics, right? And that allows us to measure our software delivery. Well, the research also identified the capabilities that are predictive of improved software delivery operations. The 4 key metrics are trailing indicators, but these are the leading indicators. When teams focus on these capabilities, they will improve their software delivery. So if we're looking here, if we start over on the left and look at what's predictive, we could start with shifting left on security. It is predictive of achieving continuous delivery, which leads to improved software delivery and operations, which is going to lead to happy customers and the business improving. So teams are achieving both stability and velocity to improve the business using these capabilities. But Sandeep, how do I go from this chart to being reliable?
In the 2021 State of DevOps report, we asked teams to rate and rank themselves across several modern operational practices, like if they were basing reliability on user-facing behavior, if they were using SLOs and sort of SLO frameworks really as a way to drive priority for the work that they were doing. We asked them also if, as automation was going up, if manual work was also going down. And then we asked them if they had a formalized incident process and protocol that they employed. And finally, whether reliability was being brought earlier into their software delivery lifecycle. Now, what we found is that SRE and DevOps really went hand in hand as we learned through the 2021 State of DevOps report. And when we looked at all the results, we found that teams who adopted those modern operational practices were almost 1.5 times more likely to report greater software delivery and operations performance, and 1.8 times more likely to report better business outcomes. So clearly, reliability was having a very positive impact on their software delivery performance. Now, we don't have time to go through a lot of depth around how to set SLOs and really what the SLO math should be. But what I will tell you is that depending on your team, depending on your approach, you want to set your SLOs that if you just barely make them, your customers are happy, and if you just miss them, your customers are unhappy. Now again, that is a tough line to figure out, but I think it really does kind of go back to that whole concept of user-facing behavior, right? If you can assess and understand what's going to be that dividing line, that's where you should set your SLO for, and no more, right? We don't want to take on any more operational burden than we absolutely have to. So you always want to start it as low as possible, and then just find that line that works for your customers. Now, SRE goes way beyond SLIs, SLOs, and SLAs, and there's also a critical kind of general operations aspect too, right? We need to know, and we need to have kind of identified and understood process for what's going on when an incident happens, what we're going to do after the incident's done, like what happened, how are we going to learn from it, and then finally, how is it going regularly? Do we have a periodic review process? So with incident status, you really need to have a very, very clearly defined and documented process. You don't want to be scrambling to send out numbers or jump on a Zoom, and just jump on a call. You should have this as a written process so everyone knows when an incident happens, we know exactly how to operate as a team. We also want to make sure that teams designate communications managers for internal users and external users. And they might be two different people, but just that there is a consistent person who is assigned to have that job and have that responsibility. And then as you're learning more about the incident, you want to make sure you're updating your incident status regularly, right? You want to be very predictable with your updates, and every time you do an update, you want to make sure folks know when the next update is coming. 5 minutes from now, 2 minutes from now, whatever works. And incidents have three main stages, right? There's detecting the incident when it starts, there's identifying what the mitigation is going to be, and there's actually deploying the fix. So that's typically how that process will go. Now, after the incident's done, this is where all of the learning happens, right? We really need to capture everyone's experience and all the data we can gather about what happened with that incident. This is going to be the sort of definitive record that we're going to look back and learn from later on. So we need to make sure we capture everything in a factual and sort of non-subjective way. And we want to make sure it's open and a collaborative way to do it too, because we need input from a lot of people, not just the team that handled it, but also all the stakeholders involved as well. The postmortem process should really be focused on resolving any potential ambiguity, right? Again, we need to have facts so we understand exactly what happened so that we can learn how to prevent it the next time around. Things like the entire timeline leading up to it, all of the contributing factors, all of this is going to help us generate a series of action items that we're going to do as part of next steps. And those next steps are going to be prioritizing, assigning, tracking, and checking on the status of those AIs and making sure they're getting done. And we also want to use this as an opportunity to assess the impact of the incident as well. Not all incidents are the same. So one that may have had little kind of business impact or little revenue impact versus another that could have had significant business impact or significant revenue impact. Those two aren't the same things. We need to really understand that because that's going to help us, again, decide how do we prioritize these action items. And then the last thing you want to do with this postmortem is make sure that it's shared amongst all of your stakeholders. Again, everyone should have a clear and transparent understanding of what happened with this incident. Now, whenever we talk about postmortems, blamelessness is a key part of this process. We want to make sure that we're doing the postmortem in a way that's not calling out any individual or any specific team, right? We should always assume that humans are working with good intentions, that no one was intending to do harm, right? Mistakes can happen. Humans are fallible. It's okay. We can use process and protocols to make sure we learn from those things and that we avoid them happening in the future. And finally, a culture of blame leads to hiding problems. And that's the worst thing you can get here, because if we don't know the problems are happening, when they do ultimately occur, it's a much, much worse scenario. So the sooner we can get blame out of the equation, the more likely people are to share and collaborate. Now, the last step in this kind of operating in a reliable manner approach is having regular reviews. And those regular reviews could happen monthly or quarterly. It just depends on what your team wants to do and what your team likes. But this is a good time to restate and review targets. So things like, are we hitting all of our SLOs? Which ones did we miss? Which ones did we not? Is there a trend in one way or the other? Because that's going to inform later on, do we need to change our plans? And do we need to change our approach around reliability? So this review process, this is where all of the important decision making happens. That's why it's critical that we document everything and we come to this review with our understanding of the problem and allow, again, stakeholders to communicate their view of the situation so that we can decide whether we need more help from humans, whether we need more help with systems, or whether we need to just change our targets altogether. Now, the last topic we want to share with y'all today is really about bringing security earlier into the software delivery process, just like we ask teams to rate themselves around reliability practices as well. Now, what we found is that elite teams who met or exceeded their reliability targets were twice as likely to have security integrated into their software delivery workflow. And teams who integrated security best practices throughout their development process are 1.6 times more likely to meet or exceed their organizational goals. So the takeaway from that really is bringing security in And bringing it earlier into your software delivery process does not slow things down. If anything, it allows teams to work faster and meet their goals at the same time. Now, we have made software complicated and more complicated every year, right? We've just added more and more attack surfaces between applications and systems and cloud platforms and on-premise hardware and CI systems, all this sort of stuff, right? The software stack has gotten more complicated. So what do we need to do to figure out how to address, sort of software and bringing security in earlier? Now, if you look at the typical software delivery process, right, it starts with developers who are writing source, they're building their applications with other dependencies, they're deploying those resources, and then kind of pushing that out to an end user. Now, from a security perspective, there are many potential insecure links here in this process, right? Developers can inject bad code or have bad code injected on their behalf without them knowing. Source control could be compromised. The build pipeline could be altered right from underneath you, or the build system itself could be compromised. The dependencies you're bringing in may have vulnerabilities, right, as part of their software. Teams could just bypass CI/CD altogether and inject bad artifacts into the delivery process. Packages could have been compromised, or a user could have been tricked into deploying the wrong image or deploying the wrong item. So there are many areas that we need to understand and establish. Now, the good news is that if we bring security earlier in, if we shift left on security and not make it a sort of runtime or deploy time problem, if we bring it in earlier, we have a better chance at catching things before they go out to production. So what we want to do is we can incorporate things like stronger end user identity and access management. We can audit our access to source control or audit our build processes to make sure they're exactly what we expect them to be. Having those build time policy checks is really, really, really important because those might be the same policies we have in production, but if we incorporate them at build time, what happens is the developers who are writing that code who may have written a potential policy violation find out now at CI time and not at runtime, which could be a much longer period of time between those two. And that build time policy check can also have vulnerability checks for things like dependencies as well. And then after that artifact is built, we want to make sure we sign that and attest that it's there and exactly what we built, along with not just the artifact itself, but the metadata around that artifact. And then we want to make sure at deploy time, we're verifying that artifact, we're verifying that metadata. And then finally, we want to keep that runtime or deploy time policy enforcement, right? That's how we make sure we can have this security all shifted left into earlier in the development process. And ultimately, we want to make sure that we do this in a way where it's not interfering and not slowing teams down, because that's the kind of stuff that drives teams to try to bypass good approaches. So we want to build a paved road here where teams feel like they can run just as fast as they were before, but they're having to deal with less operational burden later on because we're showing them all the security stuff way up front. Now, the last thing we want to leave you with today is this idea, and this is something we've learned from many years of running the State of DevOps report and years of DevOps research, which is as teams build in reliability and security and basically make their software more stable, we see teams also able to increase their velocity and deploy and deliver faster. Not just fixing bugs, but also including features and enhancements and innovation. So we know from our research that stability and velocity go hand in hand. And that's really important because our jobs, right, as helping teams with SRE should really be to make sure it's not a hindrance. It's something that's going to let them go as fast and possibly even faster over time. Thanks, y'all, for letting us share all this detail with you around DevOps and DevOps research. If you want to learn more, definitely check out cloud.google.com/DevOps. We've got a whole bunch of work that we can share with you around the research that we're doing. Or you can check out SRE stuff at sre.google. Thanks again.